Hi, everybody. This is Ted Williams, Rittenhouse Astronomical Society president. And normally, I'm the person who's lucky to be greeting possibly 100, 150 people who come out here to Muddy Run Park. We're live tonight. I'm at the park. There's nobody sitting near me. We're practicing social distancing. I have good news. The park actually opened its bathroom facilities today, and campers are now allowed to come back into the park. But everywhere in the park, everyone's practicing social distancing to go into any of the park facilities. We all have masks on. If I was going to go into the observatory tonight, I'd be wearing the mask also. Remember, you wear the mask because you're breathing possibly those virus particles out, and that actually keeps them from getting on any surface. So we even use the masks inside the observatory. Normally, I'd be welcoming you all here, and you're probably inside, and instead I'm sitting out here next to our sundial because I realize that some people might have missed this. When you guys come in for our classes or our sessions, many of you are running into the visitor center behind me, and it's already dark when you get outside and you miss the sundial. So I'll talk about that in just a moment, but I wanted to show you, I am the only one here. We are live at the park. We had hoped to have Al Ryan with us tonight, possibly looking at some stuff in the sky, but I think you can see we're fairly overcast at this time. If you look around here, the observatory is right behind me. A lot of people don't realize there's two observatories. You can only see one from this point. We'll explain that a little bit later why we have two. But boy, when I look around here, do I see quite a lot of memories. Look at that amphitheater. There's Dan McCormick out there. Wave, Dan. So Dan's about 30 feet away from me. It's safe. We don't have our masks on, and he's actually doing some of the timing for me in the background here. But boy, I have some amazing memories, and I guess I need to thank all of you. I've been with this project since its inception, almost 3 years back. I was privileged when Exelon flew me out to Chicago to actually make the purchase of these amazing ash domes. If they look like barn silos to you, that's because that's what they are. That's the rooftop of a silo. Very wind resistant, very easy to repair out here. But as I look out over this amphitheater, boy, do I have some amazing memories. I'm thinking of our Sky and Star Fest. We had a giant circus tent all the way up on the top of this hill here. We had easily some 50 exhibitors in there, and over 5,000 people shared their families with us and came out for a day of science, which was amazing. And all the different organizations around Muddy Run and the ones associated with it, some of the nature organizations, they were all also here too. One of the neatest things in my career, and you guys might remember this if you were out at the Starfest, at the very end, we were looking at that giant video screen. I was doing a star talk, and then just behind us up there in the sky was Saturn and Jupiter. And I never had this happen. We ended the Star Talk with an amazing fireworks display. And it wasn't because of me. We were celebrating the 50th anniversary of Muddy Run Park. So I miss you all. When I look around out here, it's nice to be here, but it certainly is nice to be your host. And I got to send condolences from everybody because Dave Walker couldn't be with us. He's going to be with us live later on through Zoom. We're also going to do Denise. You've probably seen her out here when she does some planet talks with us. She's done some amazing moon talks also. You know about Dan. Renee's in the background right now, and she's actually running this for us at a remote location. So I wanted to start with the sundial for a second because people don't really know a lot about it. The first thing, though, is a normal sundial would really be a lot different than this. This upward piece that you see right here in the center, it's called a gnomon, and normally that would cast a shadow. And a normal sundial would actually have a clock face, 12 hours of the day marked out along one side. And that gnomon would actually cast a shadow, and you'd be able to tell the time by that. But we have something a lot different. This is called a Renaissance sundial, and there's only two of them that have ever been made. They were commissioned through Bob Goatsman. It comes to us from Sundials LLC, Precision Sundials LLC, and he actually made this design for us. So if we understand it right, there's actually only two of them in existence. Let me get a little bit closer look here. Whoops, did I just lose you? Are you back with me? Just make sure you are there, Renee. What I've got here is I've got the gnomon, and if you look carefully at it, it seems to have like a bronze color to it. Well, what it is, it's a cylindrical piece of glass. It's indexed glass, so it actually acts like a mirror. It's not a real mirror because a mirror would have a surface, and over years that surface would degrade. But this actually focuses a reflection of a beam of light. And normally on a sundial, you might see a equatorial band going all the way around the sundial. Normally it's relating to some of the constellations of the zodiac up in the sky. But what we've got here is an amazing helix. I'm gonna try this for you guys. I'm gonna give you a little bit of a circle tour of this one. So you can see it from different angles here. The helix is actually supposed to represent the passage of time. So it's a very unique way. And on that helix, there's a time scale. That's where all the hours of the day are actually located. And what happens is there's a reflecting band that actually goes up onto the sundial itself. Let me see if I can show you a little bit closer look to this one. Here you go. A little bit dark out here right now, but you can actually see, here's the hours. They're all etched right here along this one. And the band is about 2 arc minutes across, about the size of the sun compared to this dial also. What's unique about the dial is that we can actually adjust this. We can set this, it's actually a sliding piece of brass inside of here. And what this does is we can actually align this up to daylight savings time. We can align it up to the date of the year. And it actually takes care of something that could be a whole lesson in itself, the equation of time. The equation of time kind of shows us how the sun varies a little bit about 12 noon on the meridian. And we can take that into account, making this an amazingly precision sundial. What we also can do is, you can notice the base down here, this ball, it actually has a way that you can tweak this so it can be tuned to the exact latitude that you're at. So again, you can get a very precision type of look here. What it does is it shows that bar 5 hours before noon and then 5 hours after noon, and then it slips off of there after that time. So what's kind of amazing is when we had the opening here, almost everybody, and our openings were all done during the day, they all came out here, and most of our opening pictures are all standing here next to this amazing sundial. So I wanted to bring it up tonight so that you guys get a little bit of a look at it. Normally, like I said, when you get here, it's probably dark and you're rushing right past it to go into the observatory there also. Well, like I said, our goal eventually here is to be live, and we're still working on getting a camera into our telescope for you. Al was going to try to do that with us tonight. We were actually here on site rehearsing this last night, practicing, making sure it all works, but we only have nothing to show up in the sky at this time. Although Renee did see this, I'm not so sure. Maybe she can tell me. Nah, we had the moon up there for a bit. I can't even show that out to you also. Well, anyhow, what I'd like to do is turn it over to some of the other speakers that you know of. I'll pick this up at the very end here. Hope you stay to the end with us. And like I said, oh, we have a special tonight. Not only do we have Denise and we have Dave, we've got Larry Hubble. A lot of you who've come out here for our open houses, when you go into the first dome, you probably see Denise or Dave or Mark or me or Dan. When you go into the second dome over there, that's the photograph dome. And like I said, we'll talk about this a little later. There it is. There's the second one right there. When you go into that dome, that's our CCD camera imaging dome. Larry was here just last week, and we did a little bit in case we didn't have any clear skies tonight, and he's going to treat us to a little bit of his photographic imaging. So stay tuned. We've got him hooked up at the end there, and then I'll come back live at the very end. I'd like to entice you guys to look around for 2 globular clusters, M10 and M12. So I know Renee's in the background there somewhere. Renee is our executive director. She's the one who helps us out, and she'll be switching us over here shortly. Enjoy our presentations.
Hey everybody, my name's Denise and I'm one of the educators here at Muddy Run, and I'm going to take you on a tour of what's going on in the sky, sort of like a planet report, so that you can go out and impress your friends and family, showing them where to find Jupiter or the North Star, the constellation of Hercules, whatever you want to do. So what I'm going to do is I'm going to actually share my screen, and I'm going to start with a presentation. And we are going to just check out what's up there in the summer sky. So this doesn't just pertain to tonight's date. What I'm going to show you now will follow through for the next couple of weeks into late July. And even some of the stuff might even be up through Thanksgiving. So let's start with our closest star. And that is the sun. And there have been some sunspots. These are these dark spots on the sun. That's right. Spots on the sun are called sunspots. And even though they look like holes in the sun, they're actually just cooler regions than the rest of the sun. So the sun is about 10, 11,000 degrees. We know that because of its color. It's sort of a golden color. Blue stars would be the hottest color stars, and red stars would be the coolest. Our sun is right smack dab in the middle. And these sunspots are only about 9,000 degrees. So that's why they look dark, and they look like holes because they're cooler than the rest of the sun. But these sunspots are kind of interesting because there's like disturbances going on. And if you want to think of it this way, the sun actually burps, and these burps come out as solar flares, and they happen around the sunspots lots of times. Not all the time, but a lot of times they do. Now, this is a great video. It's an oldie but a goodie from the TRACE satellite, and it shows you these arcing filaments of gases erupting from the sun in like a big giant burp. And then eventually you see particles hit the camera because the sun, when it burps, just like when you burp, if you ate something garlicky, your friend might smell it and you're like, woo, thank you for that. You know, the wind from your belch is this kind of the same thing what's happening with a solar eruption. It's like a burp. So, but instead of an odor coming out, it's X-rays, gamma rays, all kinds of weird stuff, invisible things that we can't see, but we can see it when it hits the camera. It's taken by something called the solar wind, and those particles eventually reach the Earth. And one other thing that's really cool about these arcing filaments coming here from the sunspot eruptions, they are actually hotter than the rest of the surface of the sun. So the sunspots are cooler, the sun's pretty hot, and then these eruptions are even hotter. So sometimes there's lots of them, and we call those like solar mass ejections, and they could actually knock out the power here on planet Earth. So let's move to the next slide. And this is another cool one. I saved this one. This one's an older picture from last week. But what they did is they blocked out the sun. And I got these pictures from the Solar and Heliospheric Observatory. So you can do a search for that. SOHO. Sometimes you'll get the place in New York. But this is what I wanted to show you right there. That was actually a comet that got pulled in by the sun's gravity and then probably disintegrated once it hit the sun. Because as comets get closer to the sun, they sort of melt, and the gas and dust trapped in the nucleus of the comet, excuse me, get blown out behind the comet from the solar wind. And it looks like hair. In fact, that's where the word comet comes from. It's from the word coma. And thousands of years ago, our ancestors actually thought that when comets were up in the sky, it was a princess with her long flowing hair flying out behind her. But really, the nucleus of the comet is kind of melting, and everything is being blown away by the solar wind. And every once in a while, a comet hits the Earth or Jupiter, Mars, or gets disintegrated into the sun. This was Comet Swan taking over the skies of Namibia. So a very beautiful picture. In fact, one of the best pictures of a comet I have ever seen. Okay, now the moon. We're going to have a little over first quarter moon coming up. So the moon's going to start looking like it gets bigger. And in a week's time, we will have a full moon. The moon is a great object if you're just starting out with a telescope or binoculars. because you can print a moon map, easy details. You can learn the names of the craters and find out where the astronauts landed and all that wonderful stuff. So the moon is a big, bright object, and the best time to look at it is not when it's full. It's so bright, it'll hurt your eye looking through a telescope. You need special filters. But if you look at it, the first week after new moon, that's when you don't see the moon at all, then we actually get some great views of the moon and it doesn't hurt your eye. So the moon changes. Well, at least it looks like it changes. It doesn't really. That's the phases of the moon. It's where we get our calendars from, because the moon takes about a month to go through all its phases. Now, we don't call them months anymore. We call them months. But from new moon to full moon takes about 2 weeks. And then from full moon to new moon back again takes another 2 weeks. So it's actually the sunlight shining on the sun, and depending on the angle where the earth, the moon, and the sun, what kind of angle they make in the sky, we either see a lot of the moon lit up by the sun or we see a little bit of the moon lit up by the sun. So tonight we're going to say what we would call half, because we're only looking at one side of the moon. We never get to see that far side of the moon, but technically it's called a first quarter moon. And in about a week's time, we will have the full moon. So if you're a werewolf, you might want to mark that in your calendar. So there is a few planets up tonight. The biggest one is the planet Jupiter, and it is going to be the brightest one in the sky. Now, I got these videos from the NASA webpage, so you can find them as well. They have lots of great high definition video, and this one just shows some of the beautiful clouds of Jupiter, the upper atmosphere where there's all those storms, because Jupiter's whipping around like a day is only 10 hours long. So there's a lot of turbulence in its atmosphere. We get all these clouds. We have different kinds of red spots, but this one is the most familiar, the Great Red Spot, which is a giant hurricane on the outer surface of the planet, and it's been there for at least 400 years since Galileo first discovered it in his telescope. So Jupiter is not the only planet. We also have Pluto, but you need a really big telescope to see Pluto. It's 4 billion miles away. Now, I don't have a moving video because we only flew past it a few years ago, and this is the first time we've ever even seen what Pluto looks like. So planetary scientists are still trying to figure out what is going on Pluto. We know it's cold. We know there are mountains made of water ice, and we know it is small, but, lots to learn. We're still going over that data. You're not going to see Pluto in the sky. Jupiter, yes. Pluto, no. Saturn, yes. Saturn is up very close to Jupiter. It's going to be kind of to the left of Jupiter or to the east of Jupiter, a little lower, and it's going to be dimmer. Jupiter's going to be the brighter of the two planets because Jupiter's closer than Saturn. But Saturn's a great object to look at in a telescope. I mean, Jupiter's great. Don't get me wrong. It's my favorite planet because you can see the moons. But Saturn, you get to see the rings. Now, it's not the only planet that has rings. Saturn, Jupiter, Uranus, Neptune, they all have them. However, Saturn's are the only rings that we can see through Earth, from Earth in a telescope. Binoculars, probably not so much, but even a small telescope will show you the rings of Saturn. Now, they're not going to look like we see here in these images. Once again, I got these off the NASA multimedia page, so you can find these great images and more. The last probe that actually was up there taking pictures of Saturn was called Cassini, and it recently just crashed into the planet, so we're getting data of that, but it took pictures of the moons, and we see lots of interesting details and learned about dozens of new moons of Saturn. In fact, I think Saturn has the most number of moons now, well over 80. So Saturn, not only the king of rings, but the king of moons. And Jupiter and Saturn both have moons that could possibly support life, whether they have water or they have a nitrogen atmosphere. Lots of awesome things on Saturn. So if you have a telescope, bust it out after midnight. And that's a little shot of Cassini, one of the famous pictures from Cassini of Saturn. So bust out that telescope and check out Jupiter and Saturn. All right, so let's talk about Neptune. Now, Neptune, not as exciting in a telescope because it's blue, but it's really pretty. And you're looking at Neptune. That's the furthest planet that we can see with our naked eye. So if you're in a really dark skies, you can actually see it without binoculars or telescopes. However, they do help. Most of our skies have a lot of light pollution, and we can't see Neptune very well anymore without optical aid. But it used to have a spot. It wasn't called the Great Red Spot. It was just called the Great Dark Spot. Cool thing about Neptune is it might rain diamonds, and it's kind of really close, or what we call in conjunction, or it was not too long ago, with the planet Mars. So Neptune, very blue. In fact, so blue, it was named after the god of the sea. And Mars, named after the god of war. They used to think it was made of blood because it looked so red in the sky. So that's how it got named after Mars, the god of war. However, it's not made out of blood. It's got iron in the soil, and the iron has rusted, maybe from lots of water that we believe used to be on Mars billions of years ago. So Mars is the next great adventure. There are places on Mars that we think humans could inhabit. There's water on Mars. There's not big giant oceans like we have, but there is water. It can get to be about 45 degrees there on a Martian summer day. Not very long. Most of the time it's colder than that, but it's doable. There's just no air to breathe. So we would need a spacesuit until we can terraform Mars to learn how to maybe plant some vegetables or some kind of plants that would produce more breathable air for humans. But until that time, which could be hundreds of years into the future, we definitely would need some kind of biosphere to live in, and definitely we would need our spacesuits in order to breathe. Now, these pictures were taken by the Curiosity rover, which is up there right now. It's about the size of a minivan, and it's roving around the planet. So hopefully 2024, we're supposed to send astronauts back to the moon with the Artemis project. Excuse me. We could send some women this time, so yay. Artemis was Apollo's twin sister, and Apollo was the ones that originally landed on the moon, the men. So now we're going to send some women, and that's going to be our stepping stone to Mars. Okay, there's two more planets I want to talk about. There is Uranus. Uranus does have rings, but you cannot see them. In fact, if you look at Uranus in a telescope, it looks like just a little bluish green, an aqua color dot. You know, it looks kind of like when you look at a star, which is just a small dot, but it doesn't twinkle. Planets look a little bit different as we see them through our atmosphere. So in our sky with our naked eye, planets don't twinkle, but chances are you're not going to see Uranus with your naked eye. You're going to need to know where to look, and you're going to need a small telescope or binoculars, but it's up there nonetheless. And the last planet you don't need anything to see. It was the one named after the goddess of love and beauty, the planet Venus. Now, Venus is not super exciting in this picture. I mean, you can't see anything, and that's because there's lots of clouds on Venus. They're super thick, miles and miles thick, and that means Venus is very hot. It's over 900 degrees all day, all night, making it the hottest planet in the solar system. But it's also the brightest planet as we see from Earth, because all those clouds reflect a lot of sunlight. So maybe it looks meh in this picture. However, in the real sky, it looks beautiful. That's why they thought the planet was the home of the most beautiful of the goddesses, the goddess of love and beauty, Venus. Now, Venus actually is in the morning sky. It just came out of the evening sky, but now it's in the morning sky. And Venus also goes through phases like the moon, which is amazing. Right now it's kind of close. And when it's close, it's a crescent, but it's really bright. So it's not a sliver. It's not as close as it was a couple of weeks ago, but it's still very beautiful and very bright. And you do not need binoculars or a telescope to see Venus. Okay, now let's see where these things are going to be. So what I'm going to do is I'm going to move over here to have my Sky Safari open, and I have the sky set up for just before 9 o'clock tonight, the 27th. But that's okay. Don't worry about it if you're not going outside tonight or it's cloudy. This sky is going to be up there, other than the phase of the moon and the location of the moon and little planet tweaks here and there. For the most part, this is what the sky is going to look like. So as the sun goes down, the only thing we're going to have for the next couple of days is the moon. There are no evening planets that we can see. Mercury and Venus are too close to the sun. We can't see them very good. But at the tippy top of the sky, I'm going to move time around here. Well, not move time, but I'm going to move the sky around here. And if we look at this, we see Ursa Major, the big bear. And he is great because he's almost directly overhead. So you go out, look up, he's there. These two stars in the bowl, the Big Dipper, point right to the North Star, which is in the constellation of the Little Bear, Ursa Minor. And if we look to the other side, these two stars drop down to this guy over here, and that is in the constellation of Leo the Lion. So let's look at it. Let's face the south, because if you're kind of going to go stargazing, south is kind of the best way to look because there's a lot going on there. It's the path of the ecliptic, where the planets are going to line up, where the zodiac is, all that great stuff to see. And here's two members of the zodiac right here, Leo the Lion and Virgo the Maiden. Planets, sun, moon, they're always going to be in one of the constellations of the zodiac, and here proves it, the moon is in the constellation of Virgo. So let me just move this down a little bit, and let's look at this again. So here's the Big Dipper. That's what's called an asterism. We cannot see all of the stars of the bear close to Philadelphia, but out here at Muddy Run, you can almost see the entire bear, which is amazing. Let's see if we can get what he looks like up there. Come on, there he is. So the bear, these two stars in the bowl, draw an imaginary line through them, and they point to the North Star. Once you find north, you know south is behind you. If you're facing north, west is to your left, and if you're facing west, east is behind you. So once you find one point of the compass, you can always find the other. So what else is up there? Well, these two stars in the bowl not only point to Polaris, they point down to Leo the Lion, who's this guy down here. And Leo the Lion supposedly fought with this guy over here. Now, he's not as easy to find. His stars aren't as bright, but he's called Hercules. Now, we spoke about him last month. He's got that great globular cluster, which is a big, giant glob of stars. A great place to look at with binoculars. But it was Hercules who actually fought Leo the Lion, because Leo the Lion fell from the moon, landed in a place called Thebes, and started eating everybody in town. So they were scared, called a superhero. Hercules came and saved the day. Hercules is just about at the top of the sky. The guy who is at the top of the sky is another, not a hero, but a herdsman, kind of like a shepherd. He is up there. In fact, his bright star Arcturus means bear chaser, and he's up there chasing the bears around the sky. So what about a little later? This is, like I said, just before 9 o'clock. So what I'm going to do is I'm going to move time. All right, I'm moving it pretty fast here because I'm running long, and I don't want anybody to have to sit in front of their computer too long or their phone. So I'm going to stop time here. What time are we looking at? We're looking at almost 3 o'clock in the morning. That's really late. You can go out earlier and see these guys down here. This is where Jupiter and Saturn are going to be. Pluto, if you have a giant telescope. They are in the constellations of, whoops, don't want the info, of this guy over here who's in Capricornus. I'll just do it that way. And Sagittarius, also members of the zodiac. And when you look in towards Sagittarius, you're actually looking towards the black hole in the center of the galaxy. So that's pretty cool. It's a great place. Lots of deep sky objects that I'm sure other members of Muddy Run are going to talk to you about tonight. So I'm just kind of going to show you where those planets are. Jupiter and Saturn actually are up a lot earlier. So let's move time backwards and we'll see when we can first see those guys in the sky. So let's stop time right here. By 11:30, if you have a good view of the horizon, not a lot of trees, you can definitely see Jupiter and Saturn in the sky. If you want to see Mars, you have to wait a little longer. Mars and Neptune are up probably a little bit before 2. Probably 2 o'clock will be the better time to see those guys. They're in the constellation of Aquarius and Pisces. Also members of the zodiac. Remember, the sun, the moon, the planets are always in a constellation of the zodiac. And here comes Uranus down there, heading into Aries, and Venus is in the constellation of Taurus. And now, if you're going to see Venus, you have been up for a very long time, and you will be seeing the sun shortly thereafter. After summer solstice, the nights are going to start getting longer and the days are going to get shorter, but that just means we have more opportunities to go outside, look at the stars, and enjoy the wonders of the night sky. So I want to thank everybody. I'm going to stop sharing here, and I'm going to come back. I'm going to end this presentation, but please check in with us again. We're going to have virtual information. You can also check out the Muddy Run Facebook page and my Facebook page, Stars on the Move. We post stuff there all the time. So hopefully you can check into those or Rittenhouse Astronomical Society and enjoy the summer skies, because there's a lot of fun stuff up there. We'll see you in July. Bye-bye.
Welcome back, everyone. This is Dave Walker for the Rittenhouse Astronomical Society with this installment of the Rocket Report. What's up about what's going up for 23 June 2020. Of course, what goes up must come down. And at the end of May 2020, Trampoline Futures crashed. And for those of you in on the joke, you know that means that the US launched a crewed capsule from its own soil for the first time since the conclusion of the Space Shuttle program. What did they fly? This beautiful Dragon capsule aboard a Falcon 9 rocket. And here we have a beautiful sunrise picture of the vehicle and the crew access arm. The day before the launch of Expedition 3063, the 63rd crew being sent to the International Space Station. Who are those crew? Well, they are Robert Behnken, the spacecraft commander, and Doug Hurley, Joint Operations Commander and pilot of STS-135, which was also crewed by Philadelphia area local Chris Ferguson. For both of them, this is their third trip to space. Their previous trips were aboard the Space Shuttle, including STS-128, which was the last one to take an expedition crew to the space station. The last missions were merely construction and resupply missions. They're neat guys. Definitely look up their bios. It wouldn't be a mission without their space patches. So if we take a look, we see the mission patch in the shape of a Falcon Dragon capsule with their names on it, and NASA, the US flag, and SpaceX on the bottom, and the symbology of the mission. The emblem for the Dragon capsule, the emblem for the Falcon 9 rocket against a starry background, as the International Space Station gracefully soars over blue Earth with its tenuous blue atmosphere that we all rely on. Punctuating it, the red NASA swoosh, the commercial space program emblem, and the mission number, Demonstration Mission 2, DM2, and a description, the first crewed flight since we stopped the Space Shuttle program. And if you notice closely above the D below the swoosh, there's a tiny little gray star indicating Kennedy Space Center at the southern tip of Florida, where the flight launches. Here's a beautiful picture of the rocket, pre-flight, standing on the pad, the ship is waiting, send us up a brew, say Bob and Doug, the count goes on. Yeah, there are Bob and Doug jokes including, will a future flight go from the ESA spaceport in French Guiana in South America? You know the one. Kourou, cuckoo, cuckoo, cuckoo. Couldn't resist. As far as I know, their flights are going to be taking off from Florida for the foreseeable future. And it wouldn't be a flight video without a flight video. Here we see the rocket getting ready to take off. There are beautiful high-definition vids all over the web that'll take you through the whole process. Look them up. The sound gets a little funky, so I'm going to stop here on our short 1-minute version.
3, 2, 1, 0. Ignition. Liftoff of the Falcon 9 and Crew Dragon. Go NASA, go SpaceX, Godspeed, Bob and Doug.
America has launched. So rises a new era of American spaceflight, and with it the ambitions of a new generation continuing the dream. 20 seconds into flight, stage 1 propulsion is nominal.
Plus 30 seconds into this historic mission. Flying crew on
always
board
love the little
Dragon and
counter
Falcon
across the
9, and
bottom.
look at them go.
Falcon power telemetry nominal.
And 1D throttle down.
We're throttling down to get ready for the period of maximum dynamic pressure. We're in the throttle bucket. Reports say all systems are go.
Vehicle is supersonic.
We've exceeded Mach 1 on the Falcon 9.
Yep, 0 to Mach 1 in just over a minute. Always impressive. The Falcon capsule is impressive. Currently, it's configured to carry 4 passengers up to the station. This flight only had the 2 test pilots, Bob and Doug, and a stowaway. It was traditional in the Soviet and later Russian space programs to attach a little token to the control panels of the spacecraft by a tether, and when it started kind of bobbing freely, they'd know they'd reached orbit and free fall or zero gravity, although it's not really that's a geeky thing. And here we have this shiny little critter smuggled aboard by Bob's son. If you look at it, you might want to say it's a dragon because it's a dragon capsule, but I have it on good authority that it's an Apatosaurus, not a dragon, and its name is Trevor. It's kind of cool. The scales are two-sided, so as the light shines on different parts of it, it shimmers between pink and blue. Well, it would accompany them for their next about 20 hours as this craft is taking the long approach to the space station, unlike the short rendezvous by the Soyuz spacecraft. They're doing this for the first few flights until they get all the details worked out. It gives them more time in case they have something they're not expected, but they successfully docked on the 31st of May at Docking Adapter 2. And welcome aboard Expedition 63 on International Space Station. Above the gangway, you'll note a United States flag. That was brought up on STS-135 and can only be returned from the next crewed mission launched from human soil, and that's these guys, folks. So, bravo. The mission duration will be between 30 and 90 days, depending on how experiments, tests, and so on go. And the 90 days is the duration of the rocket. Well, we know NASA has these beautiful new vehicles, but we have some old favorites and maybe some unexpected ones. Our next vehicles are going to be the Dragon, the Boeing Starliner, and Orion aboard SLS. But you might have a favorite like the mighty Saturn V aboard its mobile launch platform and its crawler. Perhaps the graceful Space Shuttle and its shuttle carrier aircraft, designed to move it around if it landed away from Kennedy Launch Center. Or the nifty little T-38 trainers the astronauts would fly to train. Traditionally, they would fly it from Johnson Space Center in Texas to Kennedy before the flight. A little more down to earth, we have the hip Astrovan by Airstream that took astronauts from every program from Apollo through Space Shuttle out to the pad. Or the new sleek electric Tesla Model X taking our Dragon crew out. But did you know that NASA, in addition to mighty crawlers, jumbo jets, and funky vans, has a railway? If you know me, you know I like trains as much as I like spacecraft. Kennedy Center has a complex railway that's designed to shuttle materials from the receiving areas from Florida East Coast Railway to where they're needed at assembly and launch sites at the Space Center. Here it's seen carrying segments of the shuttle rocket boosters across a bridge. They're in the white containers. The yellow box cars are designed to space them out for all explosion protection, you know, those little booms, and also to help distribute the weight across the bridge, so no one part of the bridge gets too much of this heavy load. While the giant tanks for SLS and Space Shuttle were built in Michoud, Louisiana, outside of New Orleans, these are built in Utah, so have to be shipped by rail. So the biggest they can be around is the smallest bridge they can go under, limiting their size. SLS needs more power in their boosters than Shuttle did, so they can't make them bigger, so they're adding more of them. And here we see the first boosters for the Artemis I SLS mission arriving at Kennedy Space Center in front of the Vehicle Assembly Building for integration and future assembly. There are some great videos. You can do a web search on Kennedy Center Railroad and find out more about this nifty little piece of overlooked technology, much used by NASA. And there you have it. NASA, our great space flight program, with everything from planes to trains to automobiles and their rockets. That's all for today. Until next time, this is Dave Walker for the Rocket Report. Keep looking up.
A lot of visitors come to Muddy Run and they wonder, why two observatories? This one we call Observatory Dome 1, and over there we have Observatory Dome 2. There's a good reason for it, because when Exelon decided to make this available to the public, they wanted one telescope dedicated for the public to come out and look through. There's somewhat of a thrill about still looking through a telescope. But they also wanted to address astrophotography, which is really how photography is done today. And that's what we do over in Dome 2. Come on in, Larry. Larry Hubble is our astrophotographer, and we just caught him outside here for a second. Larry, you say hi to our audience.
Hi, everybody.
And if you want to take us on in and tell us a little bit about the scope.
Okay, hi, everybody. My name is Larry Hubble. I'm one of the operators here at Muddy Run Observatories. And what we have here is we have our science dome. And why it differs from the one is it's always hooked up to a camera. It's always photography. There's never been anyone has ever looked through this telescope with an eyepiece. So we have an ash dome. We can see that the dome is open today. We're getting some breeze coming in. Give us some light through the video. What we have is a 14-inch primary mirror telescope. It's a plasma mirror. It's got a parabolic curve, which all that means is, in simple terms, it brings everything to a focus. When the light from the cosmos comes pouring into our mirror, it brings all that light to a focus. It's a second telescope. It's got a primary, secondary. Now the light comes through the primary mirror and hits our CCD camera. Now that's the true or the real image. In the eyepiece at the other observatory, the eyepiece, what you would do is you would put an eyepiece there and you would magnify the true or the real image. What we do here is, here in Dome 2, we photograph it. So we have the camera, and that's an SBIG, Santa Barbara Instruments, Santa Barbara, California. It has got almost what you call a full-size chip, but it's monochrome. It is not in color. So we use filter wheel. This filter wheel up here is a filter wheel, and that spins our filters around, and we can do RGB. We can shoot luminous RGB images. It's a very good comparable color, true color, when we're finished. So we also have an AO device, just to point that out. The AO device helps with seeing in the atmosphere, in which it moves at 300 times per second. And that helps the seeing in the atmosphere steady on the image chip. Okay, we are back, and I'm preparing myself here at the observatory. We're following the COVID-19 procedures. We have sanitized everything, but just with precautions, mainly for the next operator to come in from behind me, whoever that may be. We're going to go ahead and show you that we operate this observatory as the same over there with the Sky program. Demonstrate what we do here with the camera. We have the camera, we have the filter wheel. Here we go. And we can show you an RGB picture that we've taken here at MRI. Now, this image is one of our images we took, and we took that picture, which is a hydrogen and a reflection nebula. But we took the picture using these filters right here, RGB luminous. Now, after that, if you want to get into the longer, deeper, we can go to the hydrogen, oxygen 3, and sulfur. If we use those three filters and take very long exposures for many hours, we came up with this. What we originally see is the nebula M16, the Eagle Nebula, in the hydrogen, and that's pure hydrogen. Then we take a helium, nitrogen. We take the oxygen and the sulfur, but they're identical. They look just like that. And when we're done, hours of processing, we get the final process picture of the Eagle Nebula. And there we have all the colors of oxygen blue, hydrogen is the green, and the sulfur are the reds that are mixed in the sulfur. So we assign each filter to its own color palette. It's also called the Hubble telescope, or the Hubble color palette. And we use that palette to get this image in color. So that's basically it. We use the camera. We can expose the camera to 10 minutes. We normally, when we're shooting the hydrogen and the narrow band images, subframe is one image, one shot. We take as many as we can, and then the final processing, we stack those images. Once we have all three, we end up with, I gotta show you this. We end up with this beautiful image of M1, which is a Crab nebula. This is a supernova explosion. It blew up in 1054, still expanding today. But the beauty of this picture is, and I'll blow it up for you, the beauty of this picture is it looks like a rainbow, but those colors mean something. The red is sulfur, the blue is hydrogen, oxygen, the green is hydrogen. So it actually shows what wavelength this object in space is producing. So thank you. I'll round that up with the basics of what we do here at Imaging and MRI. Thank you.
Hey, I'd like to thank a couple people. I'd like to thank Denise Vaca from Stars on the Move, also Rittenhouse Astronomical Society, Dave Walker, and also Larry Hubble. Those of you who come out here with us, you've probably seen them many times. They've all been here since the inception of the project. So this is about all I can do right now tonight. If you look over my head, right there, that's our moon right there. Pretty hazed out. In fact, not one other star in the sky visible. If it does clear a little bit tonight and you get a chance to go out there and look at that, the giant large splotches that Denise talked about, the Maria or the oceans of the moon, the ones that you can see tonight, there's kind of 3 in a row right on the right hand side of the moon. The top is the Sea of Serenity. The middle is the Sea of Tranquility. Then that little dark circle all the way to the right hand side of the moon there, that's the Sea of Crisis. And then underneath all of them is the Sea of Fertility. Again, they're not craters. A lot of people, when they look at the moon, think they're seeing craters up there. Those are the Maria. And although they were formed by impacts, those Maria really have a lot more to do with the magma underneath the moon. Flowing up to the surface and hardening in those giant lava fields. So what I'd like to try to end with tonight is something we've been talking about with our members for a couple of weeks right now. I do some challenges, and what I'm going to do is I'm going to share my screen here for a second, and I'm going to use the same software that Denise was using, Sky Safari Pro. And if you remember, Denise had done a little bit of a tour across the sky, and some of the constellations she had shown us were Virgo. That's where the moon is right now. Tomorrow night, the moon would shift to the other side of that diamond that you see there, and it's just following its path around the Earth. But if you look over here, this has come up a couple times in our talks, that mysterious 13th zodiac sign. So if you take a look right now, the yellow line that you see right there, that's the ecliptic path. And the green line that you see running vertical in your screen, that's a meridian. So a meridian is imaginary. It runs from south. That's down at the very bottom there. If I were to look at the other side of the sky, way up at the top, it actually connects to north. You can see north over there on that side. It goes right through the spot that's right above your head. Look at that green label in the center there where it says zenith right there. These two lines are imaginary, but they kind of help us see the path of what's going on. Anything that's near the green line, that's about the best time to observe that object because it's making its highest passage. I'm moving back and forth right now in time, so I'm going to go right to now. And what I'd like to do is set this up because a little bit of a challenge. Renee had talked about a couple of the globular clusters that we've been talking about recently. The 3 brightest ones in the sky are M3. And if you remember, she had talked a little bit about Arcturus. That's that bright orange colored star. There's Boötes, the herdsman right there. M3 is over on the right side of Arcturus. Look down the bottom of your screen. That's M5 right there. And Denise talked about the great globular cluster up there, M13. So they make like a kind of triangle. And we've talked about that at a couple of meetings. But now I have a little bit of a challenge out there. We have a Monday night group that we've been doing called AstroQuora, and that's where our members get to talk with each other and share some of their expertise and maybe some of their questions. Well, take a look at that ecliptic path, the yellow line. It runs right through Libra. That's right in the center there. It goes through Scorpio, and you've probably heard of those zodiac signs, but look at that. It goes right through the knee of Ophiuchus. It's known as the 13th zodiac sign. Planets are sometimes a little bit above that ecliptic path. They sometimes look a little bit below that path. But that path is where you always see the sun throughout the year. And that's where you see the planets. We live in a flat solar system. So look above the ecliptic right now. And how I was finding this is I'm using the bright star Antares right about here, right down in the heart of the Scorpion. It's a bright red star, pretty easy to find in the sky. And if you look tonight, it's over in the southeast. If you wait till about midnight, it'll get over towards the south sky. And that would be the best time to look above that area. So if you look above it, you're going to see Ophiuchus, and you're also going to see an odd constellation, the Serpent. The Serpent's actually cut in half. There's a northern half where the head is, and there's a back half down below. And if you look at where his hands are, there's 4 stars that kind of make an asterism. Up here is one, a second one down here. So that's kind of like a pair there. They're pretty bright. And then these 2 right here, Yeti Prior and Yeti Posterior, the Yeti stars. So there's Yed Prior, and those 2 are very easy to find in the sky too. They're actually fairly bright. So what you do is you find those two stars. So remember, you start down here, you're at Antares, and you can see all of these in a city sky. Take your binoculars, go up a little bit and see if you can't find the Yed stars, the Yeti. And then go down below it. There's a bright star right below here, Ophiuchus, in Ophiuchus, and make a right angle and take a look. Here's M10 and here's M12. What you've got here are two amazing globular clusters. And if you look at the brightness, M12 is 6.69 magnitude. That means on a really dark sky, if you have really good eyes, you might be able to see that, but that should be easy to pick out of the sky with binoculars. Binoculars, in effect, make your pupils a lot larger. They collect a lot more light. And then look down here. Here's M10, right below that one. That too is another globular cluster. There it is right there. And look at this one. Visual magnitude is 6.5. So both of these are fairly bright. They say that in a really dark sky, and I can't remember if I saw these out in Wyoming, naked eye, but they say they can be seen. But if you look at the distance between the two, if that's M10 right about there, and let's say I measure the angular diameter, M12 is only 3 degrees apart. That means if you were to put your hand out at arm's length and you put 3 fingers sideways like a scout symbol, that would be just about 3 to 5 degrees. Most binoculars that are low power, 8 power or 10 power, should be able to catch both of those clusters. So what are you looking for when you're looking out there? Probably the oldest stars in our galaxy. What you have here are stars that are very different than our sun. Our sun is hydrogen and helium, but it's also got some heavy elements in it, nitrogen, some iron. Those heavy elements actually are not in these stars. These stars are basically hydrogen and helium. They're the earliest stars that formed in our galaxy. We think they were actually the very first ones that are on the scene, and they kind of make a giant halo around the galaxy. So there's one of them, M10, right about there. And if you look above it, here's M12 right about here. So let's take a peek at this one. And remember, what you're seeing in the software is a lot better than what you'll see in your binoculars. What you can expect to see in binoculars are kind of like a fuzzy, dim dimple of light, a little bit of a glow for both of them. But again, if you have a really dark sky, that should be doable. So as the summer goes on, this is still early in the summer for Ophiuchus, we'll still have another couple catches at it. Maybe I can give you some tips of how you can get your binoculars out and how you might want to sit out in the backyard and get yourself comfortable and see if you can make a search for something like that. Let me stop my screen share here for a second and see if I can bring the moon back in here above us. Whoops, let's see. So now I'm back, and do we have it at all? Oh, there it goes. It's so faded out of view. It's right above my finger, right above there. Well, you can't say we didn't try, everybody, and it's really great to have those of you who stayed here with us. It's dark. We're going to be shutting the whole observatory down. Again, we'll be back out here next month. Hopefully we'll get a couple more people that'll be live on the scene with us, make it a little bit more exciting. I really want to thank Larry Hubble. He worked with me on that to get that clip together for us. And Larry, you can see here almost every night he's in that second dome showing off some of his expertise also. So on behalf of Denise Vecca, Dave Walker, Dan McCormick, Renee, Stein, Al Ryan, Ted Williams. We're all behind the scenes here. We're trying to make this happen for you guys, and we'll keep bringing more of the crew back as time goes on through the summer. Thank you very much, everybody. It was a great night having you out here. Hope to have you come back next month. Bring a friend or two with you. Take care.